So I was telling you that transducer is a device which convert any physical quantities such as temperature or pressure into electrical signal. So in order to formally go into the unit called as resistive transducer, let us see more about what are the different subcomponents present in this system. Okay, in order to do so, we will first see transducer block diagram. Okay, okay. You see it consists of three subcomponents. First one is sensor, second one is signal conditioning unit, and third one is data representation unit. You see, to sensor, we are applying physical quantity to be sensed, right? I repeat this thing once more. Remember at the inauguration session, I was telling you that these days the biggest thing is what? What? Did you remember that? These days,
Sensor.
no, no, data. Everybody is speaking about data, right?
Yes, sir.
You see, who is doing the major rule in producing, not producing, in fetching data from the environment. You see, that is nothing but a sensor. So the refined word of sensor is nothing but transducer. Sensor is actually a subcomponent of transducer, right? You see, our transducer system is actually sensing the environment in order to sense the quantity under measurement for which it is designed. Is it clear to everybody?
Yes, sir.
Yes.
Yeah. You see, this is the important part of our transducer. It is actually selected. There are some many material available in the nature. What we will do is, based upon the quantity which we want to extract, we actually do the preparation of sensor by adding x quantity of metal, y quantity of metal, or it may be a class of semiconductor. What we will do is, we will do a lot of engineering in the preparation of sensor itself. Okay, the sensor is actually designed to sense the required parameter which we want to sense from the environment. So this sensor can do the job of sensing the temperature parameter, or it can do the job of sensing the pressure parameter, or it can do the job of sensing level parameter or flow parameter or displacement parameter or force measurement parameter, whatever it may be, so on and so forth. There are endless parameters for which we can design a sensor. Whatever data we want to extract from the environment, we need to first think of designing the corresponding sensor. So data fetcher is nothing but our sensor. Always remember this thing, don't forget. Hope it is clear to everybody.
Yes, sir.
Yeah. So this is the first component. But the problem with this sensor is, it cannot give information directly in measurable quantity. That is, we can measure electrical quantity. Hope you know this thing. What quantity we can measure conveniently?
Electric.
Electrical quantity.
Electrical quantity. But this sensor cannot give information in the form of electrical quantity. Can you name electrical quantity which we can measure conveniently?
Resistance.
No, we can conveniently measure voltage and current. Always remember.
Okay.
We can conveniently measure. You see, readily available ammeters and voltmeters, but it is very difficult to measure the passive parameters like resistance, capacitance, and inductance. Is it clear?
Yes.
Yeah, this sensor actually give information from environment in the form of passive quantity or some non-electrical quantity. If it is giving information in the form of passive electrical quantity like resistance, inductance, and capacitance, then also we need the other component, subsequent component called as signal conditioning unit. If suppose this is giving information In the form of non-electrical quantity also we need signal conditioning unit. Hope it is clear to everybody.
Yes, sir.
Yeah, the sensor is giving information either in the form of non-electrical quantity or passive electrical quantity. Passive electrical quantity means change in resistance or change in inductance or change in capacitance. So signal conditioning unit is actually used to transform either passive electrical quantity or a non-electrical quantity into electrical quantity. So finally, after having information in the form of current or voltage, we have the display unit available, which is here in this called as data representation unit, can do the job of displaying information. Can you give an example of data representation systems which you can see frequently in and around? What is the device you are holding right now?
Mobile phone.
Mobile phone. So which part of mobile phone is helping you to see the result?
Screen monitor.
Correct. So in transducer also we have display unit, that is nothing but monitor. So that monitor can be made up of LCD. That monitor can be made up of LED. Earlier it is used to indicating systems which measure which give the information in the form of numeric values, right? Nowadays, because of the convenient availability of digital data, we can simply get the information on our LED display or LCD displays. Hope it is clear to everybody.
Yes, sir.
Yeah, write 2 or 3 points about this block diagram of transducer. Write down. The quantity under measurement is applied on sensor is applied on sensor which transform which transform actual physical quantity into intermediate form. Actual physical quantity into intermediate form. In bracket, write down what are the different possible intermediate forms. The intermediate forms can be, in bracket, write down, change in R, comma, change in L, comma, change in C, change in C, or some non-electrical quantity, or some non-electrical quantity. You can close the bracket. You can close the bracket. You can write down the example of sensors. Example of sensor. Are you ready? Sorry, are you writing?
Yes, sir.
Yes, sir. Writing.
Example of sensors, write down. Temperature sensor. Temperature sensor. In bracket, write down RTD. We will see what is this RTD in detail later. Write down RTD. The temperature sensor you are writing RTD. It stands for resistive temperature detector. We will see in detail about this later. Hyphen and write after writing. Okay, put an hyphen and write down. Its input is surrounding temperature. Its input is surrounding temperature, and output is Output is delta R. What do you mean by delta R?
Change in resistance.
Very good. Input is what? Surrounding temperature, and output is delta R. Write down second example. Second example, write down. Hygrometer. Second example, write down hygrometer or humidity sensor. Hygrometer or humidity sensor. Write down. Its input is humidity. Its input is humidity. I hope you know what is humidity.
Yes, sir.
Moisture in air.
Very good. Its input is humidity and output is delta C. And output is delta C. Third example, write down. Third example, write down. Temperature you have written, humidity you have written. We need to see about change in L now. What example should I give? Okay, write down LVDT. 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 It stands for linear variable displacement transducer. Okay, if you are not able to write also, no problem. Simply write down LVDT because we are going to see this thing in detail. Have you written LVDT?
Yes, sir.
Yeah.
Yes.
Its input is displacement. Its input is displacement and output is delta L. And output is delta L. I think this much is enough for first component. Write a word about second component. Signal conditioning unit. Signal conditioning unit. In, are you writing?
Yes, sir.
Yes, sir.
Yeah. In general, this unit, in general, this unit do the job of, in unit, this, in general, this unit do the job of transforming intermediate quantity into electrical quantity. Do the job of transforming intermediate quantity into measure measurable. Actually we need to write measurable electrical quantity. Intermediate quantity into measurable electrical quantity. Measurable electrical quantity. In bracket write down mostly V. Mostly V. V stand for
Voltage.
Voltage.
voltage. ये याद रखना जहन में. Which is mostly used. Measurable electrical quantity बोलो तो क्या बोलेंगे? Voltage.
Voltage.
Your ADC need input as voltage. Your CRO need input as voltage, right? Your computer need input as voltage. Your display need input as voltage. If suppose there are some component which need quantity as current, then in that case we go for converting voltage into current quantity. So by default, mostly we prefer voltage as measurable electrical quantity. This is very, very important information. Okay, hope you are ready.
Yes, sir.
Yeah, the components, the subcomponents which covers in this unit are, the subcomponent which covers in this unit are write down: passive quantity into voltage converter circuit, passive quantity into voltage converter circuit, I will talk about this thing in detail later, don't worry. Second writer, filters. Second subquantity subunit, filters. Third one, amplifiers. Third one, amplifiers. Fourth one, analog to digital converters. Fourth one, analog to digital converters, etc. This much are enough, etc. Yes. Pardon me. What is the problem? Am I audible? Am I audible?
Yes, sir.
Yes.
Yes, sir. Yes, sir.
Yeah. Right about last component of transducer.
Not audible.
I'm not audible. Hello.
Hello?
Yeah, I'm not audible.
No.
Hmm. Okay, how about others?
You are audible, so please continue.
Yeah, I'm audible. It seems your system is having some problem. Okay.
No, not audible.
Okay. The last component of this transducer is nothing but data representation. Right on. It is used to it is used to display it is used to display the measured quantity in its actual unit. It is used to display the measured quantity into its the measured quantity actual unit in its actual unit, that is temperature in degrees C, level in millimeter, etc. Temperature in degrees C, level in millimeter, etc. Next point, write down: it can be made with it can be made with LCD or LED or some other technology. It can be made with LCD or LED or some other technology. So this much is enough for a block diagram. So this may come for either 3 marks or uh, a partial long answer, right? Can we go to next topic?
Yes, sir.
Yeah. The next topic of this unit is basic requirement of transducer. Are you ready?
Yes, sir.
Yeah, right on. The basic requirement of transducer. The following are the basic requirement of transducer. The following are the basic requirement of transducer, which can be clustered into two groups. First one electrical, that is A1 electrical, and B is mechanical. First cluster is electrical, second cluster is mechanical. Okay, please note down these electrical requirement quantities. First one ruggedness, second one linearity, third is repeatability, fourth is convenient instrumentation, then next is good dynamic response, then next is high stability and reliability. Please write down this thing. I will explain about each in detail.